Imagine waking up tomorrow to find out that every single drop of oil has been sucked out from beneath our planet's surface. Every oil field in Saudi Arabia, every reserve under the Gulf of Mexico, every pocket beneath Alaska's frozen tundra, all of it, gone. What would happen to the ground beneath your feet? Would cities sink into the earth? Would mountains collapse? Would the very crust of our planet crack open like an eggshell? The truth is far more fascinating and terrifying than you might think, and by the end of this video, you'll never look at the ground the same way again. Let's start with something most people don't realize. Oil isn't sitting in giant underground lakes like some kind of subterranean ocean where you could go swimming if you drilled deep enough. That's actually one of the biggest misconceptions about oil. Instead, oil is trapped inside tiny pores and spaces within rock formations. Kind of like how water soaks into a sponge. These rocks, usually sandstone or limestone, have millions of microscopic holes and cracks where oil has been stored for millions of years, held there under immense pressure from the layers of rock above. The oil is squeezed into these spaces so tightly that it can't escape on its own, which is why we need to drill and pump it out. Now, when we extract oil from these underground rock formations, we're not creating massive empty caverns like you might imagine. Instead, we're emptying out those tiny pores and spaces, one drop at a time. But here's where things get interesting, and a little bit scary. When oil is removed from these rocks, something has to fill the empty space left behind, because nature absolutely hates a vacuum. In many cases, water starts seeping into those empty pores, gradually replacing the oil that was there. This process happens naturally over time as underground water flows through the rock formations. Sometimes, the rocks themselves begin to compact and squeeze together, kind of like how a wet sponge shrinks when you squeeze the water out of it. This compaction is what causes one of the most serious consequences of oil extraction, something called subsidence, which is just a fancy word for when the ground sinks.
Land subsidence is the lowering of land level.
Let me paint you a picture of what subsidence actually looks like in the real world. In California's San Joaquin Valley, one of the most productive agricultural regions on Earth, the ground has sunk by more than 28 feet in some areas. That's as tall as a 2-story house. This didn't happen overnight. It took decades of pumping oil and groundwater from beneath the surface, but the result is dramatic and, in many ways, irreversible. Buildings that were once level now tilt at odd angles. Roads crack and buckle. Bridges no longer line up properly with the roads they're supposed to connect. And water canals that once flowed smoothly now have to be constantly repaired because they've changed elevation. In some coastal areas around the world where oil has been extracted for decades, the land has sunk so much that seawater has rushed in, flooding communities and turning what was once dry land into marshes and lagoons. The city of Long Beach, California, experienced this firsthand during the mid-20th century when the Wilmington oil field was being heavily exploited. Between the 1930s and the 1960s, parts of Long Beach sank by as much as 29 feet, causing massive damage to infrastructure, homes, and the harbor facilities that the city depended on for its economy. Buildings cracked, the naval shipyard became unusable in certain areas, and the risk of flooding increased dramatically. Engineers eventually had to inject water back into the ground to try to stabilize the subsidence, a process that costs millions of dollars and requires constant monitoring even today. But subsidence is just one piece of this underground puzzle. Let's talk about something even more unsettling: earthquakes.
Oklahoma and other states where fracking is widespread have experienced rising numbers of small earthquakes.
Yes, removing oil from beneath the earth can actually trigger earthquakes. And this isn't some wild conspiracy theory. It's a documented scientific fact that has been studied extensively over the past few decades. Here's how it works. When oil is stored in underground rock formations, it's usually under tremendous pressure, and that pressure actually helps stabilize the rocks, keeping them locked in place like pieces of a complex 3-dimensional puzzle. When we remove that oil and the pressure drops, The rocks can shift and adjust to the new conditions, and sometimes that adjustment happens suddenly and violently, causing the Earth to shake. Even more concerning is what happens when we inject water or other fluids back into the ground to maintain pressure in oil fields or to dispose of wastewater from drilling operations. This practice, called injection or re-injection, can actually lubricate fault lines deep underground, making it easier for them to slip and causing earthquakes that wouldn't have happened otherwise. Oklahoma is the perfect example of this phenomenon, and the numbers are absolutely staggering. Before the year 2000, Oklahoma experienced roughly 1 or 2 earthquakes per year that were strong enough for people to feel. But by 2015, that number had exploded to more than 900 felt earthquakes in a single year, a nearly 500-fold increase. Scientists have directly linked this dramatic rise in seismic activity to oil and gas extraction activities, particularly the injection of wastewater deep underground. These aren't just tiny tremors that rattle a few dishes. Some of these earthquakes have been powerful enough to damage buildings, crack foundations, and cause genuine concern about public safety. In 2016, a magnitude 5.8 earthquake near Pawnee, Oklahoma, was the strongest earthquake ever recorded in the state's history.
The earthquake tied a 2011 record as the strongest ever recorded in Oklahoma.
And researchers determined it was almost certainly triggered by wastewater injection from oil and gas operations. Now, you might be wondering, if we removed every single drop of oil from the entire planet, would the Earth just collapse in on itself like a deflated balloon? The answer is both reassuring and complicated. The total volume of oil ever discovered on Earth is estimated to be somewhere around 3 trillion barrels, which sounds like an absolutely massive amount. And it is, by human standards. But here's the thing. Compared to the total volume of the Earth, it's actually incredibly tiny, almost insignificant. The Earth has a radius of about 4,000 miles, making it a sphere with a volume of roughly 260 billion cubic miles. The oil we extract comes from depths usually between 5,000 and 30,000 feet below the surface, which is only a tiny fraction of the Earth's total radius. Even if we removed every drop of oil that exists in the ground, we'd only be affecting a very thin layer of the Earth's crust, not the planet as a whole. But that doesn't mean there wouldn't be consequences. Dramatic, widespread consequences that would reshape landscapes and societies around the world. If we suddenly removed all the oil from every oil field on the planet at once, the immediate effects would vary depending on the geology of each region. But certain patterns would emerge almost everywhere. In areas where oil fields are found in soft, poorly consolidated rocks, like many coastal regions and river deltas, we would see massive, rapid subsidence, with the ground sinking several feet or even tens of feet within months or years. Cities built on or near these oil fields would experience catastrophic infrastructure damage. Skyscrapers would tilt and crack, highways would buckle and become unusable, underground pipes carrying water and sewage would break, causing massive leaks and contamination, and entire neighborhoods might become uninhabitable as buildings shifted on their foundations. Coastal cities would be hit especially hard because as the land sinks, the ocean doesn't sink with it. It rushes in. Places like Houston, Texas, which sits atop massive oil reserves and has already experienced subsidence, would see neighborhoods flooded as the ground drops below sea level. Venice, Italy, which is already struggling with sinking and flooding, would face even more severe challenges if nearby oil fields were completely depleted all at once. In the Netherlands, parts of which are already below sea level, rapid subsidence from oil extraction could overwhelm the elaborate system of dikes and pumps that keep the North Sea from flooding millions of people. The economic costs would run into the trillions of dollars, and millions of people might be forced to relocate to higher ground, creating refugee crises unlike anything the modern world has seen. But let's zoom out from individual cities and think about what would happen to the Earth's tectonic system if all oil were removed simultaneously. The Earth's crust is divided into massive plates that float on the semi-molten rock of the mantle below, and these plates are constantly moving, grinding against each other, sliding past each other, and sometimes colliding with tremendous force. The oil trapped in underground rock formations exists within this crust, and while it doesn't directly control tectonic movement, its removal can influence local stress patterns in the rocks. If we suddenly removed all oil from the planet, we'd effectively be creating millions of tiny zones of weakness throughout the crust. Places where rocks have compacted, where pressure has dropped, and where the ground is more prone to shifting. Scientists call this induced seismicity, and it would happen on an unprecedented global scale. Imagine fault lines around the world, places where tectonic plates meet and where earthquakes naturally occur, suddenly becoming more active because the rocks around them have been destabilized by oil extraction. The San Andreas Fault in California, the North Anatolian Fault in Turkey, the Alpine Fault in New Zealand, and countless other seismic zones could experience increased earthquake activity, not necessarily because new energy is being added to the system, but because the removal of oil has changed the stress balance in the rocks, making it easier for stored energy to be released. The result could be a global increase in earthquake frequency and intensity, affecting billions of people who live in seismically active regions. Now, here's something that might surprise you. In some ways, removing all the oil might actually have some unexpected benefits for the Earth's subsurface environment, though these would be vastly outweighed by the negative consequences. When oil is extracted, it often brings up other substances that have been trapped underground for millions of years, including toxic chemicals, heavy metals, and radioactive materials that can contaminate groundwater and soil if not handled properly. If all the oil were gone, there would be no more reason to drill, and the risk of these contaminants reaching the surface through drilling accidents or improper waste disposal would effectively drop to zero. Additionally, oil extraction often involves the use of chemicals for hydraulic fracturing or fracking, which can pollute underground water supplies that millions of people depend on for drinking water. Without oil extraction, this source of pollution would disappear. But these small environmental benefits would be like finding a penny on the ground while your house is burning down. Technically a positive, but absolutely dwarfed by the disaster happening around you. The physical damage to the Earth's crust from removing all oil would be severe and long-lasting, potentially permanent in many cases. Unlike forests that can regrow or polluted rivers that can gradually clean themselves, compacted rock doesn't uncompress, and land that has sunk doesn't rise back up on its own. Engineers can attempt to mitigate subsidence by injecting fluids back into the ground to prop up the rocks. But this is expensive, technically challenging, and can only slow the process, not reverse it. In many cases, communities affected by severe subsidence would have no choice but to abandon their homes and relocate, leaving behind ghost towns slowly being reclaimed by nature or swallowed by rising seas. Let's talk about one more fascinating and frightening aspect of this scenario. What would happen to the enormous underground infrastructure that the oil industry has built over the past century and a half? There are millions of wells drilled into the Earth's crust, some reaching depths of over 30,000 feet, each one creating a potential pathway between the surface and the deep underground. When these wells are no longer needed, they're supposed to be properly sealed with concrete and steel to prevent fluids from flowing between different rock layers. But the reality is that many wells, especially older ones, are poorly sealed or not sealed at all. If all the oil was suddenly gone and the ground began to shift and compact, these wells could become conduits for disaster. Groundwater could flow down through abandoned wells into deeper rock formations where it would mix with brine, extremely salty water that naturally exists deep underground, becoming contaminated and useless for drinking or agriculture. Conversely, toxic fluids from deep underground could migrate upward through compromised wells, emerging at the surface and poisoning soil, streams, and rivers. Methane gas, which often accompanies oil deposits, could escape through old wells and either accumulate in basements and underground spaces, creating explosion risks, or leak into the atmosphere, where it would contribute to climate change far more powerfully than carbon dioxide.
The cost of plugging most of the nation's abandoned and unplugged wells could be more than $250 billion.
The cost of properly sealing all the abandoned and orphaned oil wells around the world has been estimated in the hundreds of billions of dollars, money that few governments or companies are willing to spend. Which means this ticking time bomb exists right now, even before we consider the scenario of removing all oil from the ground. Here's something that really puts this into perspective. Humans have been extracting oil from the earth for only about 160 years in any significant quantity, which is less than a blink of an eye in geological terms. Yet in that short time, we've altered the structure of the Earth's crust in ways that will persist for thousands or even millions of years. The rocks we've compacted won't uncompress, the faults we've activated will remain more prone to earthquakes, and the land we've caused to sink will stay sunk unless we invest enormous resources into trying to reverse it. We've essentially conducted a massive, uncontrolled experiment on our planet's geology without fully understanding the consequences. And we're only now beginning to realize the scope of what we've done. Scientists who study this phenomenon use sophisticated computer models to simulate what happens underground when oil is extracted, and their findings are sobering. They've discovered that the effects of oil extraction can propagate outward from the original drilling site, affecting areas miles away through a complex web of interconnected rock layers and fault systems. Remove oil from one location, and you might trigger subsidence or seismic activity somewhere completely different, somewhere that hasn't seen any drilling at all. It's like pulling on one thread of a sweater and watching the whole thing start to unravel. Except the sweater is the Earth's crust, and unraveling it could endanger millions of lives. But let's bring this back to the original question with a clear answer. If we removed all the oil from beneath the Earth's surface right now, the planet itself would survive just fine. The Earth has been through far worse, including asteroid impacts, supervolcano eruptions, and ice ages that covered half the planet in glaciers. The oil represents such a tiny fraction of the Earth's total volume that its complete removal wouldn't threaten the planet's existence, or even significantly alter its overall structure. However, for human civilization, the consequences would be catastrophic and would unfold across multiple timeframes. In the immediate term, days to months, we'd see mechanical failures in active oil fields as pumps ran dry and pressure systems collapsed. But the real problems would start within months to years as subsidence accelerated in vulnerable areas. Cities would sink, infrastructure would fail, earthquakes would increase in frequency and intensity, and millions of people would be displaced. Over the longer term, decades to centuries, the environmental damage would compound as abandoned wells leaked contaminants, as groundwater systems became permanently altered, and as coastlines shifted due to subsidence and rising sea levels working in terrible combinations. The economic cost would be almost incalculable, easily reaching into the tens of trillions of dollars globally. And the human cost in terms of lives disrupted, homes lost, and communities destroyed would be immeasurable. The fascinating irony in all of this is that we're actually conducting a version of this experiment right now, just in slow motion. Every day we extract millions of barrels of oil from the ground, and while we'll never remove every drop, we're steadily working our way through the easily accessible reserves. The subsidence in California's San Joaquin Valley, the earthquakes in Oklahoma, the sinking of Venice and coastal Louisiana, these aren't hypothetical future scenarios. They're happening right now, today, as a direct result of our hunger for oil. The only difference between the thought experiment we've been exploring and our current reality is the speed at which it's happening. Remove all the oil at once, and you get catastrophe within years. Remove it gradually over a century, and you get a slow-motion catastrophe that's easier to ignore, but ultimately affects just as many people. So what can we do about this? The obvious answer is to transition away from oil dependence as quickly as possible, not just because of climate change, which is itself a massive threat, but because of the direct physical damage that oil extraction causes to the planet we live on. Every barrel of oil we leave in the ground is a barrel that won't contribute to subsidence, won't trigger earthquakes, and won't create environmental problems for future generations. But we also need to deal with the legacy of a century and a half of oil extraction. The abandoned wells that need to be properly sealed, the subsiding regions that need to be monitored and potentially protected with levees or other infrastructure, and the seismic zones that need better building codes and early warning systems to protect people from induced earthquakes. The story beneath our feet is one of incredible geological forces, human ingenuity, unintended consequences, and a planet that's more interconnected and fragile than we often realize. The ground you're standing on right now has been shaped by millions of years of geological processes. Layers of sediment compressed into rock, ancient seas that evaporated leaving salt deposits, dead organisms that transformed into oil under heat and pressure, and tectonic forces that folded and fractured the crust into the landscape we see today. We've tapped into this ancient system to power our civilization, and in doing so, we've become a geological force ourselves, capable of reshaping the Earth in ways that will echo through deep time. When you think about what would happen if we removed all the oil from beneath the Earth, you're really thinking about our relationship with the planet itself, about whether we're careful stewards of the only home we have, or reckless exploiters who take what we want without considering the cost. The answer, as with most complex questions, lies somewhere in between. We've accomplished remarkable things with the energy that oil provides, lifting billions out of poverty, enabling technologies that seem like magic just generations ago, and connecting the world in ways that would have been impossible without cheap, abundant energy. But we've also damaged the very foundation our civilization rests on, and those damages are becoming harder to ignore with each passing year. The Earth beneath us is shifting, sinking, and shaking in ways both subtle and dramatic. And whether we choose to acknowledge it or not, we're running an experiment with our planet's geology that we can't easily undo. So, the next time you're standing on solid ground, take a moment to think about what's happening miles below your feet. About the empty spaces where oil used to be, about the rocks slowly compacting, and about the immense forces that keep our planet stable, or not so stable, depending on what we choose to do next. And if you want to uncover another disturbing mystery hidden beneath the surface, watch the video on your screen about the murder kits buried across America.